Good morning, fourth graders. Today we're on page 155 of your student journal, page 155. And our objective today is, today I will solve word problems with mixed numbers. So today I will solve word problems with mixed numbers. So we're going to have a mixture of addition and subtraction word problems. So you're going to have to look for operation words to help you decide what you're doing. Okay, let's look at our vocabulary. Our first one is reminding us about an improper fraction and how an improper fraction is equivalent to a mixed number. And remember, we've looked at this. The reason that 5/4 is the same as 1 1/4 is because 5/4 is equal to 4/4 plus 1/4. Because my numerator is 4 and 1 equal 5. And anytime a numerator and a denominator are the same, that's equal to 1. So that's how we get 5/4 turned into 1 1/4. And that this is called our mixed number. And then they're just reminding us what a numerator is and what a denominator is. Okay, our steps today say we're going to determine what is being compared using a T-chart. So we don't really need this first line. We're just going to use a T-chart. So we are going to use a T-chart. And then it says we're going to fill in the chart with known information and determine the operation. So this all kind of just goes as one step. So we're going to use a T-chart and fill in the information. So we're going to fill in information and the operation. Okay, then we're going to solve using a number line, a model, or the commutative property of addition. Okay, so I like the commutative property of addition, but if it's a subtraction problem, we obviously can't use that. So if it's a subtraction problem, I'm going to use a model. So I'll probably use this strategy for addition and this strategy for subtraction. So if that's the case, you're going to want something to shade with. So I have my crayons, because if I'm going to be using area models, I'm going to want something to shade with. So you might want to pause the video and grab something. Okay, then I'm going to write the fraction equation and solve. Okay, so I'm going to get started and show you what this looks like. Here's my first problem. It says, Carlos painted 1 4/8 of the bedroom in his house in the morning. He then painted 1 1/8 of the bedrooms in the house in the evening. What fraction of the rooms in the house had he painted by the end of the day? Okay, so what do we have? In the morning, Carlos painted 1 4/8. That's what that told us. 1 4/8 in the morning. It says he then painted. Okay, so if he then painted, that means he did more. So I'm going to do an addition. So in the evening, he painted 1 1/8. So I'm going to add that, because when it says he then painted, that then makes me know I'm going to be adding. Okay, so I know my equation then is 1 4/8 plus 1 1/8. Okay, so I could use different strategies. I think for this, I'm just going to use my commutative property strategy, which means I'm going to decompose my mixed numbers. And then I'm going to rewrite using the commutative property, and I'm going to group my whole numbers and group my fractions. Then I'm going to add my fractions. Add my whole numbers and add my fractions. And then I'm going to add them together to make a mixed number. And then I'm going to make sure I don't have an improper fraction, which I don't. 5/8 is not improper. So my answer is 2 5/8 is how many of the rooms in his house he had painted by the end of the day. Okay, let's look at another one of these. Here's my next one. And it says Sasha's family invited the Garcia family to join them for pizza. Sasha's family ate 1 3/6 pizzas. The Garcia family ate 2 2/6 pizzas. How much pizza did the family eat together? Okay, so what do we know? Sasha's family ate 1 3/6. So we can say Sasha's family had 1 3/6. Okay, then we can say that the Garcia family ate 2 2/6. And the question says, how much pizza did the families eat all together? So all together tells me they want me to add those. So again, I have another addition problem. Okay, so let's look at this. We have 1 3/6 plus 2 2/6. So I'm going to use my commutative property again and say I have 1 plus 3/6 plus 2 plus 2/6. And then I'm going to group my whole numbers and group my fractions. Then I'm going to add my whole numbers and add my fractions. And then I'm going to put them back together as a mixed number. And then finally, I'm going to see if I need to fix my improper fraction, but I don't. 5/6 is not improper, so I can leave it. So my answer is 3 5/6. That's how much pizza they ate all together. Okay, so ladies and gentlemen, let's do some together. We're on page 156, and here's our first problem. It says, Lucas has 3 2/8 pizzas left over from his baseball banquet. After giving some pizza to his friend, he has 1 3/8 pizzas left. How much did Lucas give to his friend? Okay, so let's do a T-chart over here. And we have Lucas has 3 2/8 pizza. Okay, after giving some to his friend, okay, he has 1 3/8 left. Okay, and the key word left tells me we're going to do some subtraction. We're going to do some subtraction there. I'm not really going to label this friend because that's really just telling us how much is left. We'll find out how much he gave his friend. Okay, so our equation is 3 2/8 take away 1 3/8. Okay, so we can't obviously use the commutative property of addition since it's subtraction, so I'm going to use an area model. So for an area model, what I'm going to do is I'm going to draw what I have. Okay, and what do we have? We have 3 holes, 1, 2, 3 holes, okay, plus I have 2/8, so I'm going to need another box. Okay, that's what we have. Okay, so now I'm going to shade in what I have. Okay, so I have 3 holes, and then I have 2/8. So I need to, my denominator 8, and it's going to be really small. Sorry, friends. Really small there. My denominator says 8, so I had to divide my whole into 8 parts, and my numerator of 2 says I have 2 of them. So that's what 3 2/8 looks like. Okay. They want me to take away 1 3/8. Now when I subtract, I want to subtract with my fraction first. So they want me to subtract 3/8. So 1 2/8. I don't have enough, so I need to break another one up. So I'm going to break this one up. And I took away 2 pieces, so I'm going to take away 1 more. And I apologize it's so small, friends. They also want me to take away 1 whole. So what do we have left? We have 1 whole left, and how many parts do we have here? 1, 2, 3, 4, 5, 6, 7 eighths. So our answer is 1 7/8. That's how much he must have given to his friend. Okay, let's look at another one. A mixed juice recipe calls for 1 3/4 cups of cups of orange juice and 3 2/4 cups of pineapple juice. How much juice is needed altogether? Okay, so what do we have? We have orange juice is 1 3/4, and then we have pineapple juice is 3 2/4. And the question says all together, so they want us to add those. So we have 1 3/4 plus 3 2/4. Okay, I'm going to use the commutative property. So I'm going to say 1 plus 3/4 plus 3 plus 2/4, and say 1 plus 3 plus 3/4 plus 2/4. So we get 4 plus 5/4, and I'm running out of room, so I get 4 5/4. Okay, but we know we can't leave 5/4 because it's improper. So what do we know about 5/4? I'm going to come over here and write it. I know that 5/4 is equal to 4/4 plus 1/4, which is 1 1/4. So we know 5/4 is the same as 1 1/4. So we're not going to use 5/4, we're going to use 1 1/4. So we know that we have 4 wholes plus 1 whole is 5 wholes, and 1/4 as our answer. Okay, friends, if you need to pause the video to make sure you have all that before you stop it, you might want to do that. Have a wonderful day. Bye-bye.